So the first thing that we're going to do is we're going to work on this problem right here. We're going to try to generate sine of 2x, sine of cosine of 2x, and tangent of 2x. And we're given information that we have the tangent of -5/12 and that we're in quadrant 4. So when we do that, quadrant 4 is this one right here. And so we know that tangent is, remember, tangent is of theta is equal to y over r. So that tells me that I'm going to go down 5 and that my radius is going to be 12. So this is 12, this is a -5, and now our triangle that we're trying to make is going to be this one. And so this is going to form a right angle, and we know that this is going to be a 7, and the reason that we know that that's a 7 is because of by the Pythagorean Theorem. So you guys could do that. That'd be x squared plus y squared is equal to r squared, and we didn't know x squared, but we do know that that's a -5 squared is equal to 12 squared, and that would yield plus or minus 7. So that's how we got that 7. Now for sine of 2x, to do this information, and I'll do them each in different colors so you guys can see. I'm going to get sine of 2x. The formula is, remember, 2 sine of x cosine of x. And so it's going to be 2 times. Now sine of x is going to be, Zara, can you mute your mic? Or here, I'll do it. Sine of 2x is going to be that -5 over 12, and that's because it's y over r. And then cosine is going to be 7 over 12, and that's because cosine is x over r. And so what we're going to end up getting is a -120 over 169. That is our sine of 2x. Okay. For cosine of 2x, that formula, we can use 3 different kinds. It doesn't matter which one we use. They're all going to work out just fine. But let's just say that we use 2 cosine squared of x minus 1. So we're going to get 2 times, and cosine, remember, is 7 over 12 in this case, squared. Wait, ooh, I messed up. I messed up. My bad. I'm glad I caught this. And I'll explain it to you guys in just a second. I'm sure someone else saw this. Yes, I didn't look at the what you guys had texted on there. I just caught it right now. Thank you. I have this triangle wrong. It's probably because I'm doing all this silly technology stuff. But so let me start over. My apologies. Shoot. Tangent, geez. Tangent of x is actually y over x, not y over r. I was thinking sine for some reason. My apologies. Bear with me as we're going through this whole online world. I'm trying more to think about the technology than I am about the math. So from here then we know it's going to be -5 is my y plus 12 squared is equal to my r squared, and that's what I'm looking for. Thank you guys for texting me that. Silly me. So it's going to be 25 plus 144 is equal to r squared. So then r squared is equal to 169, and so r is equal to 13. Thank you. Geez. So it's going to be 2 times a negative 5 over 13, and then 12 over 13, which is going to give me that negative 120 over 169. Hope that helps. I honestly hope I didn't confuse you guys. And then going back to cosine of 2x, I'm going to use that same one. But then cosine is x over r, so that's going to be 12 over 13 squared minus 1, which is going to give me 2 times 144 over 169 minus 1. And so that's going to give me 288 over 169. And then with common denominators, I'm going to go 169 over 169. That will give me 119 over 169, and that is cosine of 2x. There's that. Here is this one. I'm grateful that you guys are paying attention. This is crazy. All right, and then they want us to find tangent of 2x. And so tangent of 2x then is going to be tangent of 2x is the same as going sine of 2x over cosine of 2x. This is another way that we can do this problem. And this is the reason I'm using this one is because I have sine of 2x and cosine of 2x. I already have their answers, so that's the faster way to do it. And so I'm going to go a negative 120 over 169 over 119 over 169. And so what happens here is we're going to multiply by the reciprocal. So I'm going to get a negative 120 over 169 times 169 over 119. And that's going to give me a negative 120 over 119. And that is my tangent of 2x. So there is that guy. Is there any questions on this? Are you guys okay with this first problem here? You guys can feel free to text in just so I know. I don't want to go too fast for anybody, so I want to make sure that you guys are okay. All right, I'll take silence as a yes, I guess. So, all right, so let's go on to number 20. And here's 20. So we're given sine of 17 degrees and cosine of 17 degrees. And so we can actually use some formulas for this. And so what I'm going to do is to try and simplify this using the double angle formula. And the double angle formula, just so you guys know, is sine of 2 theta is equal to 2 sine of theta cosine of theta, right? Now, what we're given in this problem, though, is sine of 17 cosine of 17. So we have both thetas, but we don't have that 2 in front. So what I'm going to have to do is I'm going to have to divide. So I'm going to go sine of 2 theta divided by 2 is sine of theta cosine of theta. Now from here, I'm going to be able to plug in the numbers that we've got. And so the number that we have for our angle is 17. So it's going to become sine of 2 times 17 degrees over 2 is equal to sine of 17 degrees cosine of 17 degrees. Okay? So then sine of 34 degrees over 2 is equal to sine of 17 degrees cosine of 17 degrees. So basically what I'm trying to show you here is how how to take a decomposed trigonometric function and make it into a double angle. Now with this one we have tangent for number 21, and so with tangent of 21, we know that 2 tangent theta over 1 minus tangent squared theta is equal to tangent of 2 theta, right? And so from here, we can see what this is going to be. And so look at the theta that we have. Our theta, instead of being just theta, isn't our theta divided by 2? So then what's going to end up happening is this guy here is actually going to be tangent of 2, but my theta is theta divided by 2, right? So then that means that we're going to get tangent of theta. Okay, so does that make sense to you guys? We use the formula, and I'll just highlight the formula so you guys have it. We're going to use this formula that we've learned prior, and then from there, using tan of 2 theta with the angle that they gave us in the blue to plug in for theta, and then the 2's are going to cancel each other out, and so we just get tan of theta. So this problem ends up being 2 tan of theta divided by 2 over 1 minus tan squared of theta divided by 2 is going to be equal to tan of theta. All right? Cool. All right, so let's go on to the next example. This is number 22. And so number 22, for us to be able to decompose that, let's see if we can do this. So some of the rules that we know are, we know that cosine of 2 theta has a rule that says cosine squared of theta minus sine squared of theta, right? It's an identity that I've taught you guys. We also know that the identity is 2 cosine squared theta minus 1, or it could be 1 minus 2 sine squared theta. Those are the 3 identities for cosine of 2 theta. But we can see in this one that the one that we clearly want to use is going to be this one, right? Because we have cosine squared of an angle minus sine squared of an angle. And so if we use that, don't we get, our angle in this case is going to be 2 theta over 5, correct? So then what's going to be is that thing is going to equal cosine of 2 times 2 theta over 5. And so that's going to give us an answer of cosine of 4 theta over 5. And that is, well, that's terrible. That is our answer. Okay? Any questions? Just trying to make sure that you guys are okay. Okay. Feel free to interrupt me at any time. But all right, let's keep going. Now, now we're going to do some manipulations so you guys can see, because this is important. I'm going to generate these half angles. So these are some more identities that you guys are going to want to know. So please work on memorizing these for the future. I know that I'm going to be letting you guys use notes on the exams and quizzes, but as you go higher and higher in mathematics, this is going to be important for you guys to know, and so you should memorize them. Now what I'm going to do here is I'm going to show you how these came about, at least two of them, and go from there. So if I solve for theta here, solve for sine of theta, what I'm going to get is I'm going to move the 1 over, so I'm going to get cosine of 2 theta minus 1 is equal to a negative 2 sine squared theta, right? Then I'm going to move the negative over, so I'm going to go 1 minus cosine of 2 theta is equal to 2 sine squared theta. Again, just trying to isolate for the 2 sine theta piece. Now, I want to solve for sine theta, so I'm going to put that on the left-hand side. So I'm just going to switch my equal signs. So I'm just going to go 2 sine squared theta is equal to 1 minus cosine 2 theta. Then I'm going to divide by the 2. And so I'm going to get 1 minus cosine of 2 theta all over 2. And then to get rid of the square, I'm going to take the square root of the other side. So sine theta is going to be equal to plus or minus the square root of 1 minus cosine 2 theta all over 2. And you can see that this is sine of theta. Now, the one thing that they're going to do to make it look a little bit different, and I want to show you this, and it's important because it's half angle, right? See this theta and this 2 theta? If I change it to theta over 2, and that's what they're going to do here. I should have written a little bit smaller. I'll do it up above so you guys can see it. If I say alpha is equal to, or alpha over 2 is equal to theta, don't I end up with sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine. Now, if I go alpha over 2 times 2, doesn't that just become alpha? And then over 2. And that's the only thing that they're doing here, is they're doing a substitution of alpha over 2 for my theta. Okay? And I'm going to do the same thing for cosine. So I'm going to solve for cosine of theta. So to solve for cosine of theta, I'm going to solve for this guy right here without getting rid of the square root. So I'm going to have cosine of 2 theta plus 1 is equal to 2 cosine squared of theta. Then I'm going to divide by 2, the whole thing, right? So I'm going to get cosine squared of theta, and then square rooting both sides, but I'm going to switch it over so it looks like the formula for you. All over 2, and then it's going to be cosine of theta is equal to plus or minus the square root of cosine of 2 theta plus 1 all over 2. But again, let me write that a little bit nicer. It's kind of crammed. Cosine theta will be equal to plus or minus the square root of cosine of 2 theta plus 1 over 2. And we can see here again, if we do that alpha substitution, I can do this one here. I'm going to get cosine of alpha over 2 will be equal to plus or minus the square root of cosine of alpha plus 1 all over 2. Now, to do tangent would simply be the sine over the cosine, and that would yield that third example. Now, one of the important things that you need to know is this. What quadrant you're in is going to be determined, what sign you have, whether it's a plus or a minus, is going to be determined by what quadrant you're in. So let me do some examples to explain that to you so that you guys can benefit from this. So let's do an example real quick with these. So number 23 here, it says use the half angle formula to find the exact value of sine of 67.5. So what we're going to do is we're going to say, all right, 67.5, we're going to let alpha over 2 equals 67.5. So that tells us then that alpha should be equal to 135 degrees. Okay? Does that make sense to everybody? Okay. Now from here, once I have the alpha of 135, I'm going to use the formula. And it's said in the problem that they want sine of 67.5 degrees. So then I'm going to go, all right, sine of 135 degrees divided by 2 is equal to, and now since we're at 67.5 degrees, aren't we in quadrant 1? So this is telling me that we are in quadrant 1. So sine is positive. So our square root will be the positive choice. And we're going to go 1 minus cosine of 135 degrees divided by 2. So that's going to give me square root of 1 minus, and so cosine of 135 degrees puts us in quadrant 2. So that's going to be a negative radical 2 over 2, and you guys can find that on your unit circle. So that's going to give me 2 plus radical 2 over 4. And we can clean this up a little bit, and this is what it'll look like. Your final answer should look something like this. 2 plus square root of 2 all over 2, because the square root of 4 is 2. And so this is our final answer. Okay? Again, the trick is we're going to let our alpha over 2 equal the desired angle that they want. All right, that was in degrees. Now let's try it in radian. So in radian, in this example now we're trying to get cosine of 5 pi over 8. And so since we're doing cosine, let's set this up. So 5 pi over 8, we're going to let alpha over 2 equal 5 pi over 8. And so that's going to give me that alpha is 5 pi over 4. So then we can go ahead and do this. So we're going to go cosine of 5 pi 5 pi over 8, which is the example that we want, or we could have gone over 2, right? 5 pi over 8 over 2, but that's fine. What quadrant are we in 5 pi over 8? 5 pi over 8 puts us in quadrant 2. That's going to be something important for you guys to look at. So looking at the unit circle, we're bigger than pi over 2, but we're smaller than pi. And so that puts us in quadrant 2. And so what we're going to end up with is cosine is negative in quadrant 2. And we're going to get square root of 1 plus cosine of 5 pi over 4 divided by 2. And so we're going to get a negative square root of 1 plus cosine of 5 pi over 4 is a negative radical 2 over 2 over 2. And so we see that this is going to be a negative radical 2 minus radical 2 all over 2. So oh, that messed up. Cut that. This is our answer to this one. Are there any questions on this at all? No? Okay. All right, so let's keep going. If no one has any questions, we'll keep moving forward. And so here's example 25 for you guys to look at. And so it says, suppose that sine is equal to 3 pi over 5. And we're restricted to the second quadrant. This right here is giving me the domain of the angle. So this is something that's important. That right there is telling me that we are in quadrant 2, right? So we know we're sine of 3 over 5. So sine, remember, is y over r. I know I have that right. So then if I draw a triangle, because I think it'd be useful to have a triangle, sine is 3, 1, 2, 3, and then our radius is 5, and so the triangle that we end up is this one. So if this is 3 and this is 5, we can go ahead and find out what our x is. And so we're going to go x squared plus 3 squared is equal to 5 squared. And so x squared plus 9 is equal to 25. And so x squared is equal to, well, I don't want to do plus minus quite yet, equal to 16. So x is equal to plus or minus square root of 16. And since we're in quadrant 2, my x should be a negative 4. Okay, so now we have that information. They're asking us to find two specific things: cosine of 2 theta and tangent of, sorry, not 2 theta, theta over 2 and tangent of theta over 2. So let's go ahead and find our cosine first. So cosine of 2 theta, remember, is equal to plus or minus the square root of 1 plus cosine theta over 2. Why did I do? I wrote down the wrong. This should be theta over 2, not 2 theta. That's the formula. And so if we were to divide, if we're in quadrant 2 and we divide the angle in half, doesn't that tell us that we're in quadrant 1? Because any number in quadrant 2 under 180 divided in half puts us in quadrant 1. So this angle ends up being in quadrant 1, right? So that tells me then if we're in quadrant 1, shouldn't our result end up being positive? So when I plug in values, I'm going to end up with a positive root answer. But I'll just demonstrate it so we can get to the get to it. So I'm going to get, all right, plus or minus square root of 1 plus, now cosine of theta is going to be a negative 4 over 5, right? That's because of our x, and that's divided by 2. And that's all under the square root. So then we're going to get plus or minus square root of 1/5 over 2, which is equal to plus or minus the square root of 1 over 10. And like I said, we're in quadrant 1, so it is the positive case. And then we can leave it like that, or you could rationalize it. And if you rationalize it, it's radical 10 over 10, and it is positive. Either one of these will work for you. Okay? Now to do the tangent, we've got to remember some things, right? So it told us that we were in quadrant 2. But if we're going to take the half angle, again, that puts us in quadrant 1. And so then we're going to get tangent of theta over 2 is going to be equal to plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. But again, since we're in quadrant 1, we know it's the positive case. And so since we have the positive case, it's going to be square root of 1 plus 4 over 5 over 1 minus 4 over 5. And the reason I'm getting those numbers is because, again, remember, I'll just write it. Cosine of theta is equal to a negative 4 over 5, because this is a negative 4 for the x distance. And so that's going to give me 9/5 over 1/5 rooted, which when we simplify that is going to be square root of 9, which yields 3. Okay? All right. Any questions? Are you guys with me? All right. Now, for the next example, we are looking at cosine alpha is a negative 15 over 17. Again, we're given degrees in this case, not radians. I'll just highlight it. So this here is the quadrant that we're in, and so that puts me in quadrant 2, correct? That puts me in quadrant 2. But if we're going after the half angle, then the half angle, half of alpha is going to put me in quadrant 1 again. So when we're looking at sine and tangent, they're going to be in quadrant 1. So that tells me that we're going to get the positive cases for both of those, correct? Okay, so let me go ahead and do sine. So then sine of alpha over 2. Before I even do that, let me find out what my y would be. And so cosine is x over r, so then x squared plus y squared equal to r squared, would give me x squared plus a negative 15. I messed up. I have x, I'm looking for y. So it's a negative 15 squared plus y squared is equal to 17 squared. And so y ends up being let me do the math real quick. Should be 8. So we got our 8. And so then to do sine of alpha over 2, it's going to be plus or minus the square root of 1 minus cosine alpha divided by 2. So then we know that cosine is negative 15 over 17, so that's going to make it a plus. All of that divided by 2. And so we're going to get 32 over 17 divided by 2 rooted, and it's positive. That's going to give me 32 over 34 rooted, which we can clean up a little bit to be, I should have just done the division. It's 16 over 17 rooted, and we could clean that up to be 4 over the square root of 17. And again, that is positive, and so if we wanted to rationalize it, we could, but this is okay for me. Now, to do the tangent, and I'll do that in a different color so we can see it, to do tangent of alpha over 2, put a line to separate these guys. I'm going to get tangent of alpha over 2 is equal to plus or minus the square root of 1 minus cosine of alpha over 1 plus cosine of alpha. And we know what cosine of alpha is, so we can do that. And so we're going to get, again, the positive case. And so it's going to be 1 plus 15 over 17 over 1 minus 15 over 17. And this really should all be rooted. And then that cleans up mathematically to be 32 over 2, which ends up being the square root of 16, which gives us the answer of 4. And so, oops, my answer for this one is 4. And again, that's just fraction manipulation, but that's where that is. And then we're almost done. All right. Now, for the proof of the identities, we're going to do these identities here. When we're doing proofs of identities, we choose one side or the other to work on. And so typically what I end up doing is I end up working with the left-hand side. I have a bad habit of always working with the left-hand side. I just get stubborn. But you can choose which side you want to work on, okay? So there's no problem there. So I'm going to choose to work with the left-hand side, so I'll just write that down. I'm going to work with the left-hand side. And so what I'm going to do is I'm going to go, all right, tangent of x times 1 plus cosine of 2x. And what I'm going to try to do is see if I can change these things to everything to be in terms of sine and cosine. So I'm going to go sine of x over cosine of x. And then on the inside, what I'm going to do is I'm going to go 1 plus, and then what I'm going to do with the cosine of 2x is I'm going to use one of the formulas that we have. So I'm going to change that to 2 cosine squared of x minus 1. And that's one of this guy right here is one of the identities for cosine of 2x. And the reason I use that one is because it eliminates the one that's in the parentheses with it. So I'm going to get sine of x over cosine of x. And on the inside, what I'm going to end up having is 2 cosine of x squared. But one of the things that's neat here is this cosine is going to take away that power. And so I'm going to end up with sine of x times 2 cosine of x, right? And that can be written as 2 sine of x cosine of x. And that is an identity that we have, right? Isn't that sine of 2x, which is the right hand side? So we have our QED. Okay? Cool. Now, to do the other identity, we have, we're going to go, all right, again, I said I'm stubborn. I like to use the left-hand side. I think there's more to work on the left-hand side, so it gives me more freedom. And the trick that I'm going to do is I'm going to turn everything that's tangent into sine and cosine. So I'm going to go, all right, left-hand side, I'm going to go 2 sine of x over cosine of x all over 1 plus sine of x over cosine of x, that whole thing squared. Give me 1 second, please. And then from here, I'm going to just try to clean this up. And so cleaning this up, I'm going to get 2 sine of x over cosine of x, and then the denominator, I'm going to get 1 plus sine squared of x over cosine squared of x. And then what I'm going to try to do on the denominator is get a common denominator. And so I'm going to get 2 sine of x cosine of x over cosine squared of x plus sine squared of x all over cosine squared of x. You guys should see that. Now, one of the things that's cool is cosine squared of x plus sine squared of x is 1. So I'm going to get 2 sine of x over cosine of x all over 1 over cosine squared of x. Now, when we divide by a fraction, we need to multiply by the reciprocal, correct? And so I'm going to get cosine squared of x over 1. But This cosine is going to take away the square. And so we're going to end up with 2 sine of x cosine of x. And again, it's the same identity. So we end up with sine of 2x, which I believe is that right-hand side. Okay? That's all for notes 7. So I'll stop my recording so I can post on YouTube for you guys.